Hello everyone. I'd like to welcome you to my hands-on workshop, a hands-on introduction to SAS data step hash programming techniques. I'm Kirk Lafler, and I'll be conducting this hands-on workshop today. As a SAS software user since 1979, I've worked in a variety of capacities as a consultant, application developer, programmer, data analyst, educator, and author. The presentation objectives will be to understand hash objects. We're going to explore the world of hash objects from an introductory point of view. Then we'll turn our attention to the basic hash object syntax. We'll explore the syntax related to using the hash objects themselves. Then we'll turn our attention to hash object examples. I'll cover examples from search or lookup to match merging techniques and sorting, both ascending and descending sorts. The tables or data sets that we'll use in all the examples will be the SAS help.cars table, consisting of 428 observations or rows and 15 variables, and a table or data set that we'll create during the hands-on workshop itself, called work.colors. It will consist of 6 observations and 3 variables. Let's begin. We'll start looking at and understanding hash objects themselves. What is a hash object? Essentially, it serves or acts like a data structure. It provides an efficient mechanism for fast data storage and retrieval. It's implemented in the SAS system as a data step construct. It's not available in PROCs or procedures. It essentially contains an array of items that maps keys to their associated or respective values. At the end of the data step process, the hash object is automatically removed. How does a hash object work? The contents of a table are read into memory once. SAS can then repeatedly access the memory as often or as necessary as it needs. Assuming that memory-based operations are nanosecond speeds, they're typically faster than disk-based, which are millisecond speed operations. Consequently, users experience faster operations. Using the 2 tables, the SAS help.cars and the colors table, we have a key called type on both tables. And we're going to see later on how we can match merge these 2 tables together based upon the key. Now let us turn our attention to basic hash object syntax. Like any language, hash objects has its own unique set of syntax that we'll explore and learn. The hash object is used by calling methods. It looks and behaves oftentimes like a function. There's 26 known methods. The basic syntax consists of the name of the hash table, which is essentially user assigned, followed by a dot, the desired method by its name, and any specifications or arguments that need to be passed to the method. Some examples, just a couple, and we'll explore these further later. HashKey.defineKey, where we're going to define a key, and HashKey.find, where we're going to perform a lookup or a search. Now what I've done here is I've listed alphabetically the 26 known hash object methods. The methods that are listed here in white, we will not cover in this hands-on workshop, but the methods that are listed in blue, such as the add, define data, define done, define key, find, and find next, will be illustrated in one or more of the examples that we're going to cover in this hands-on workshop. Continuing alphabetically, we see that we have has next and output methods. The ones listed in blue, again, will be covered in examples later on in this hands-on workshop, where you will be able to try them out and experiment using your own version of the SAS software. Whether you use SAS 9.4, the licensed version, or the SAS University Edition, doesn't really matter, because the hash objects exist in both software versions. And then finally, in alphabetical list, here are the remainder of the hash object methods. Now, the methods that I'm not going to cover in this hands-on workshop, as well as all the ones I do, can be found with further details in the references that I have listed at the end of this presentation. So I list many references that you'll be able to find more content, should your curiosity be there, and how to use, how to apply, and then work with the hash objects themselves. Now let's turn our attention to some actual hash object examples. In this first example, our purpose is to create a cars color dataset or table. We're going to use the sashelp.cars table or dataset, and we're going to create this new dataset, a temporary dataset called work.colors. It has three variables: type, which is a character variable, exterior color, and interior colors, which are all character variables. And as you notice here, the data lines, we're going to actually type in the physical data lines, which consists of 6 observations or rows, into this code, followed by the semicolon and then the run. Essentially what this code is going to do when you execute this code is it will define and create the cars color data set consisting of the 6 rows and 3 variables. And it's going to look something like this when you print them, either using PROC print or SQL select or some other procedure to display the data. Notice if you've entered the information incorrectly, all the data lines, you'll see that the data all lines up correctly under each one of the variables themselves. And just to validate and verify, we have the ability to use PROC print or PROC SQL to actually display the contents of the work.colors dataset or table. Here I'm showing PROC print using the bar statement, or PROC SQL using the select statement and the from clause. And when you choose whichever one you're familiar with or prefer to use, and then when you're done, go ahead and submit that and run that code in order to verify and view the contents of the work.colors dataset. And if you've entered all the data in correctly in the data lines and your code worked, checking your log, make sure that everything is correct and there are no data errors or no syntax errors of any type, you should see the work.colors data, the 6 observations or rows and 3 variables. Now we're going to look at how to conduct or perform a hash search or lookup. A search or table lookup operation is a common task performed by hash objects. The result of a hash search or find operation produces a result of a single observation that matches a user-specified search criteria. The following methods will be used: define key, define data, define done, and find. In exercise 3, I'd like for you to start entering this code. So in this first statement, the data statement, we're going to initiate and create and name a temporary SAS dataset to store the results from our hash object processing. And just to keep the resources down, we're going to use the keep equals dataset option as well, just to list out origin, type, make, model, and MSRP. Now this statement, if 0, then set sashelp.cars. This technique allows you to capture metadata from whatever data set we're processing, in our case, sashelp.cars. So we can use and parlay that information into the hash object itself. Next, we're going to enter origin equals USA. And you can use, as long as they're bounded, single quotes or double quotes. In this case, I'm using single quotes to assign the variable and character string value that will be used for search or lookup purposes. And then what we're going to do is just the first iteration through the data step. Now keep in mind, a data step will iterate as many times as there are records or observations. In this case, we're using the automatic variable, the automatic system variable called _n_ to tell SAS that just the first iteration through the data step, we want to declare the name of our hash object as hcars. That's a user-assigned name. And the data set that we want to point to is sashelp.cars. And we also want to define the key as origin. And we also want to define the data that we want to keep as type, make, model, and MSRP. And then we're going to tell it we're done. The next thing we're going to do is we're going to use the find method to determine whether the specified key is found in the hash object. And then issue the stop to stop our step. Putting this all together, this data step itself, when executed, is going to create a hash object in memory, collecting or capturing the information from the metadata information from the sashelp.cars, parlaying that to the hash object itself. So it's going to carry on and pick up the metadata being defined as data about data or information about data. And just like we did in exercise 2, in exercise 4, we're going to look at the result set from that data step hash object execution. We can use PROC print or PROC SQL. We'll repeat this over and over for each one of the major examples. Of course, you can use PROC report or PROC tabulate and other things, but just to keep it simple and to concentrate just on the hash object, I thought let's just use PROC print or PROC SQL, whichever you're familiar with, just to explore the result set. In this case, it found USA, SUV, Buick, Rainier, and the MSRP. With the default action of the hash object, once it finds a value in the hash object, it automatically stops. Now let's turn our attention to how we can actually process a data set where multiple observations are associated with the key. In other words, you have duplicate observations of the key. We're going to use a lookup with find, has next, and find next. We're also going to specify when we declare the hash, assigning the name, the multi-data yes argument. Now the different methods we're going to use for this are define key, define data, define done, find, has next, and find next. Now the code itself, the font I use is a little bit small, but I wanted to try to get it all on one slide rather than bounce it across 2 or more slides. So I apologize for the size of the font that's being used here, but I just want to go over what the code is. First thing we want to do, we want to create a data set to store our results to, and then we want to capture the metadata from the SAS help.cars. And just like we did in exercise 3, when we did a search or a lookup, the first iteration through the data step, if underscore n underscore equals 1, and only the first iteration of the data step, we're going to declare a hash, assign a name, and point to the SAS help.cars as our data set that we want to read. And with multi-data yes, define our key as origin, define our data type, make, model, MSRP, and then define done. Then, let's say we just want to look at USA manufactured cars from the SAS help.cars data set or table. We can say do origin equals USA. If hcars.find equals 0, then do. Essentially what we're doing is we're assigning the variable and character string value to be used as our key. Perform a lookup with the find method to determine whether the key exists in the hash object, and if it does, output the contents to the SAS dataset. Then traverse the dataset looking for other data values that match the key. And it continues looping through this, collecting all the observations that match origin equals USA. That multi-data yes and the looping technique that's used here, along with the has next and the find next, gives us the ability to find all the origin USA manufactured cars or anything else that we want to use. And just like we did in the previous exercises, we want to actually use PROC print or PROC SQL to observe or view the results of our hash object to see what was collected and what was stored in the data set. So in this case, our data set that we created in exercise 5 was work.hashSearchAll, and we want to display the origin, type, make, model, and MSRP. Now, as you see, the results are much more than the exercise 4, because in this example, in this exercise, what we're doing is we're collecting all the USA manufactured cars and not stopping at the first result or the first successful match. It's going to collect them all and store them or save them out to the SAS dataset. In our next example, we're going to turn our attention to performing what's called as a hash, match, merge, or join. Now you can perform all different types of joins or match merges. In this particular case, we want to create an intersect represented in the Venn diagram by the teal or the cyan colored AB circle. The hash data step construct uses the following methods to perform a match merge: define key, define data, define done, and find. So the intent here is just to find the intersect. In exercise 7, we're going to once again use the hash object in a data step to create a data set called, in our case, work.hashMatchMerge. We want to then use if 0, then set work.colors. We're going to capture or collect the metadata from the work.colors data set that we created in exercise 1. And like what we've done in the past exercises, the first iteration through the data step, and we only need to do this once, is we need to build or define or declare our hash object. In this case, it's going to be called hcolors, and it's going to point to the data set work.colors. We're going to define our key as type and define the data that we want to keep and maintain in our data set, exterior color and interior color. Then we're going to tell it we're done. Then we're going to perform a disk-based read from the SAS help.cars dataset. We're going to do this with the set statement. Now this is a disk-based read, so yes, this is a little slower than if we were to bring it into memory and then process it in memory. But the one thing we've done here is we've gone ahead and read into memory the work.colors. The SAS help.cars is being read and processed from the disk or the server. And then finally, we're going to use the find method to determine whether the specified key is found in the hash object, and then output the results to the data set that we created on the data statement. So if hcolors.find, the key is the type variable equals 0, then output. Now that output is the output statement. We're going to see a little later, we're going to use the output method. So this program is going to create a match merge data set. We're going to store the results to work.hashMatchMerge, capture our metadata from the work.colors, and basically parlay that to the hash object itself that we're declaring and defining in memory called hcolors. We're defining our key as type, our data exterior color and interior color in the hash object, and then we're going to read the SAS help.cars as a disk-based operation and then process the match merge just as if we were doing a data step merge or an SQL join with the intersect. Exercise 8, we're going to, just like we've done before, use either PROC print or PROC SQL to view the results just to make sure that we've done them correctly and created a intersect from the two tables, SAS help.cars and work.colors. And we can see that we have all the variables that we've specified here: origin, type, make, model, and MSRP from SAS help.cars, and type and exterior color and interior color from the work.colors table. And these are matches. So when you run this exercise 8, exercise 7, and exercise 8, make sure that you delve into the details so you can learn the whole process. Now we're going to turn to the next type of application that we can perform with hash objects. It's called a hash sort. Sorting is a common task performed by all SAS users. Using hash programming techniques, SAS users have an alternative to using the sort procedure. Now, I'm not saying to use this over PROC sort or whatever sorting mechanism that you're using. But this is another thing you might want to put in your skill set. The methods to perform a sort is define key, define data, define done, the add method, and then the output method. So we're going to explore 2 new methods that we haven't seen. In this exercise 9, just like we've done before, we're going to use the data step. In this case, we're not going to actually name our data set on the data statement. We're going to use the underscore null underscore, because we're going to use the output method to name our data set later. If 0, then set sashelp.cars, capture and collect the metadata from the sashelp.cars table or data set. The first iteration through the data step, we're going to go ahead and declare or define our hash object. In this case, we're going to name it HSort. And notice we have an ordered A. As you can imagine, we want to perform an ascending hash sort. So the A stands for ascending. And then we're going to define our key as MSRP. And you can change that around if you prefer to use a different key. We're also going to define what data we want in the result set with our define data method, origin, type, make, model, and MSRP, and then tell SAS that we're done. We're then going to perform a disk-based operation using the set statement against our sashelp.cars. Notice we want to set up an indicator. End equals EOF, EOF standing for end of file. And then what we're going to do is we're going to use the add method. We're going to use this add method basically to add data to the hash object. And when we're processing the last record, the end of file, if EOF or if end of file, then using the output method, we want to write the results to a data set that we assign. In our case, we're going to call it work.hashSorted. So this program is a very useful way to perform sorts using hash. And it basically follows previous examples for the most part. Now it does include the add method and the output method, because I wanted you to see how those work. And then when you output the results, they're automatically going to be ordered in ascending order based upon the key. In our case, we define the key as MSRP. And just like we've done before, we want to inspect or view and verify that our hash object worked as we expected and hoped. So we can use PROC print to display the work.hashSorted data set, or PROC SQL to display the information to our output or to our results window. And we can see from the results, if you look at the MSRP column, the last column in this data set, the MSRP is in ascending order by the dollar value for each one of the cars. So it looks like it worked well. Now, I only printed out the first 20 records or displayed the first 20 records, but there's over 400 records that are contained in here. And of course, you can subset, etc., in the hash object or in your PROC print or PROC SQL to reduce the size of the result set. In exercise 11, we're going to reverse the sort order, and we're going to perform a descending hash sort. Just like we did in exercise number 9, we're going to say data null, and then if 0, then set sashelp.cars, capturing or collecting the metadata from the sashelp.cars dataset or table. The first iteration through the data step, if _n _ equals 1, then we're going to declare our hash and name it, called HSort. And this time we're going to say ordered D for descending. And the D can be uppercase or lowercase, doesn't matter. Just has to be enclosed in either single or double quotes that are balanced. Then we're going to define our key, define our data, and tell it when it's done. And just like we did before, I'm showing here a set statement to perform a disk-based read from the sashelp.cars dataset or table. And we're also setting up an end-of-file indicator with the end equals parameter that we're going to use at the very end of this program. Just like we saw with the ascending hash sort, now that we're doing a descending hash sort, we still need to be able to add data to the hash object, and we're going to do this with the add method. And then we're going to execute if end of file when we're processing the last row or last observation. What we want to do is we want to output using the output method to a data set that we want to write to. In our case, I'm showing here work.hashSorted. It's a user assigned name. So all the results in descending order by MSRP are going to be written to work.hashSorted dataset. So this descending hash sort routine essentially captured the metadata from the data set that we want to read data from, sashelp.cars. The first iteration through the step, we want to declare or define our hash object, calling it HSort, telling SAS that we want the data set to be ordered in descending order by the key MSRP. And just like we did before, exercise 12, we're going to issue a PROC print or a PROC SQL so that we can view or display the results from our hash object that we wrote to perform or emulate a descending hash sort in exercise 11. So once this code is entered, either PROC print or PROC SQL, you run it, you'll be able to see the results on your results window. And if you look at the MSRP column, the very last column in the results, you can see that the largest values for manufacturer suggested retail price appear first, and gradually as you go down the number of rows, you see that it's getting smaller and smaller. So it looks like our descending hash sort worked correctly. In conclusion, I wanted to give you an understanding of what hash objects are, what their purpose is. Essentially, they give us the ability to efficiently read, manage data because it takes advantage of real memory. And memory speeds are faster than just disk-based processing. We then turned our attention to basic hash object syntax. I showed you that there's alphabetical list of 26 different methods. We looked at about 8 of those methods in various examples. And then we looked at hash object examples. We did a search or lookup type of process where it found the first occurrence and it automatically stopped. We then turned our attention to how we can process and search or look up duplicates. And then we looked at how to perform a match merge and then sorts. Further reading and research. There are a number of wonderful books, papers that are available to SAS users throughout the world. Paul Dorfman and Don Henderson in 2018 came out with their book on data management solutions using SAS hash table operations, a business intelligence case study. It's published by SAS Press. You also notice that Paul Dorfman and others have written papers, and these papers can all be found on lexjansen.com. Peter Eberhardt in 2011, and then in 2018 I also wrote and presented a paper on hash objects. So there's a number of hash object papers and wonderful resources. A little self-publicity. I'm a SAS Press author. I have written a book for SAS Press called PROC SQL Beyond the Basics Using SAS. It's currently in its third edition. The third edition came out in 2019. It's available at SAS Press as well as Amazon.com and many different online booksellers. I want to thank you for viewing this hands-on workshop, and I also want to thank Lisa Mendez, the SAS Global Forum 2020 Conference Chair, the SAS Global Forum team, and SAS Institute for all their hard work in making SAS Global Forum, the 2020, the virtual event, happen. And I also want to thank all of you for taking the time to view my hands-on workshop. Should you have any questions, please feel free to reach out to me. My email is right here, kirklafler@cs.com, or LinkedIn if you'd like to connect there. I'd be happy to do that. Again, thank you so much. Have a great virtual event, SAS Global Forum 2020, and I definitely look forward to meeting you and seeing you at a future conference. Bye now.